What do we make of the new interstellar visitor, labelled 3I Atlas? When astronomers pointed telescopes at this object in late 2025, it behaved like a comet, glowing and sprouting jets of gas and dust as it warmed. Yet Harvard astronomer Avi Loeb has put forth a dramatic claim. The combination of traits seen in 3I Atlas is so odd that it cannot be a comet. Could he be right? Or are we witnessing ordinary cometary physics at work? We will plunge into the data, asking pointed questions. What natural processes could produce sunward jets or extreme brightness? How can an icy rock come nearly exactly from the plane of the solar system or flare blue-white near the sun? Each twist raises debate. Is this object a freak of nature or simply a very unusual comet? Loeb's team has enumerated a dozen anomalies in 3I Atlas behavior. These include, for example, the object orbit. It follows a retrograde path that lies almost exactly in the ecliptic plane of the planets, within about 5 degrees. Loeb calculates the chance of that coincidence as only 0.2%. They note a sunward jet, sometimes called an anti-tail, visible in mid-2025 from July through August and again in November, that seems to point toward the sun instead of away. They say the nucleus mass is huge, roughly 1 million times heavier than the first interstellar object Oumuamua and 1,000 times heavier than 2I Borisov, all while travelling faster than either. They observe that its arrival path was fine-tuned so that it skimmed within tens of millions of kilometres, or tens of millions of miles, of Mars, Venus and Jupiter, yet remained hidden behind the Sun at perihelion. They report an outgassing chemistry anomaly, a gas plume unusually rich in nickel relative to iron, far beyond normal comet ratios, and almost no water, only about 4% of the mass. Loeb also points to extreme dust properties. The scattered light from 3I Atlas shows unprecedented negative polarization levels, and even a sky direction coincidence, because it came within about 9 degrees of the famed 1977 WOW radio signal direction. Near perihelion, the object brightened faster than any comet seen before, and its reflected light appeared bluer than the sun. Finally, Loeb lists 2 startling effects involving jets and acceleration. Symmetric sunward and anti-solar jets that would demand an absurdly large surface area of sunlight absorbing ice to drive them, and a significant non-gravitational acceleration implying evaporation of roughly 13% of the object mass. Yet images taken after perihelion show the object intact. So if it did lose that mass, it must have stayed together. The last anomaly is that multiple narrow jets stay tightly collimated over 1 million kilometres, or more than 600,000 miles, without smearing out, despite the body-measured 16-hour rotation. Taken at face value, these points seem to stack up against 3I Atlas being a typical comet. But each mystery has drawn scientific pushback grounded in rock-solid cometary physics. Let us examine each in turn and see whether normal processes might explain them. The orbit alignment can happen naturally. Interstellar objects come from random directions, so if one happens to line up with the plane of the planets, that is simply chance. The statistical surprise is only apparent because Loeb calculated a probability after the fact. In truth, astronomers caution that using such probabilities after observing the orbit is a classic statistical fallacy. The comet retrograde yet near ecliptic trajectory could simply reflect that many passing objects intersect the inner solar system near the orbital plane of the planets. After all, most debris ejected from distant systems will, by chance, enter from or near the ecliptic at some time. Planetary scientist Steve Desch and others note that nothing in physics forbids such an alignment. It would be more surprising if an interstellar object never lined up with the ecliptic. So the orbit is not evidence of anything unnatural. It merely happened to cross the plane. The sunward jet, or anti-tail, is unusual but not unprecedented. Many comets have complex dust tails, and when viewed from Earth at certain angles, a fan of ejected dust can appear to point sunward. In fact, two main mechanisms can produce an apparent anti-tail. One is a perspective effect. As a comet swings around the Sun, we sometimes look down the plane of its orbit so that trailing dust spreads out on both sides of the nucleus. From our view, it can look like a tail pointing toward the Sun. Loeb argues this was not the case for 3I Atlas, but such optical illusions have been well known for decades. The other cause involves grain sizes. If a comet ejects relatively large dust particles slowly, those grains may not be swept away by sunlight or solar wind as quickly as tiny grains. Instead, they linger along the comet orbit, both ahead of and behind the nucleus. If the nucleus is spinning and venting chunks of debris in two opposite directions, one can see a bright streak toward the Sun, as well as the usual tail. Studies of solar system comets, for example Comet C 2014 UN 271, have shown sunward enhancements from large grains released on the day side. In short, the sunward jet of 3I Atlas can be a natural dust-tail phenomenon, and comet experts have worked out these models for 50 years. What about the immense nucleus mass that Loeb proposes, measured in millions of times Oumuamua? This claim rests on interpreting the slight non-gravitational drift in the orbit. But Wright and others note that the acceleration data are too uncertain to pin down such a mass precisely. Loeb's assumption required an extremely precise measurement, on the order of a few parts in 10 billion in astronomical units per day squared. But in reality, the comet fuzzy coma makes the positional accuracy much worse, more like 1 part in 10 million. When that uncertainty is accounted for, the implied mass can be lower by orders of magnitude. In short, the high mass inference is highly questionable. And even if 3I Atlas were quite massive, perhaps tens or hundreds of meters across, meaning roughly tens or hundreds of yards across, this alone would not violate physics. The only odd part is that we have never seen that many large interstellar rocks. But that is simply a sampling issue, since we only know 3 such visitors. None of this proves it is artificial. It simply suggests that 3I Atlas may be at the large end of the natural size spectrum for comets. Next, Loeb points out that 3I Atlas's entry timing was fine-tuned to skim close to Mars, Venus and Jupiter, while being hidden behind the Sun at perihelion. Critics again chalk this up to statistical misdirection. Almost any random interstellar trajectory could come near some planets when passing through the ecliptic, and it would also randomly have some view of the Sun. And the claim that being unobservable at perihelion is anomalous is self-contradictory, because he calls both being close and not close anomalous. This is more an issue of arbitrary probability arguments than of physics. In reality, 3I Atlas's path is not implausible for a comet. As one colleague put it, Loeb's reasoning begs the question. Finding any passing comet near planets is not surprising when we look at all possible cases. Moving into the outgassing mysteries, Loeb reports that the gas plume chemistry is startlingly different from typical comets. He cites spectroscopic measurements showing an excess of nickel and almost no water. Only about 4% of the outgas material was H2O. The rest being mostly carbon compounds, cyanide, nickel-bearing molecules and other gases. It is indeed true that 3I Atlas appears unusually metal-rich and water-poor compared to normal comets, or even the interstellar object 2A Borisov. However, planetary scientists point out that comets can vary widely in composition, and interstellar comets may not match our expectations from solar system comets. Some comets, especially very distant or extrasolar ones, might have ices rich in carbon monoxide or carbon dioxide and complex organics, which would cause them to release much less water near the Sun. In this case, 3I Atlas was still quite far out, roughly 2 to 3 astronomical units from the Sun, when those spectra were taken. Carbon monoxide and carbon dioxide ices sublimate much more easily than water at those distances. Loeb's team notes the extreme nickel-to-iron ratio, similar to an industrial alloy, but Wright notes that there is no standard iron-to-nickel ratio for comets, as they vary with location and history. If 3I Atlas began with an exotic mixture of materials, such as more rocky minerals or metal-laden dust, it could simply outgas nickel more efficiently than most comets, especially in cold conditions. In other words, the metal-rich and water-poor signature is notable but not inexplicable. Chemistry depends on the object's specific makeup and temperature, so a very different chemical fingerprint is expected for an interstellar comet. It is not evidence of machinery, only of unfamiliar ice composition. Loeb also flags the extreme light polarization seen in 3I Atlas's coma. When sunlight scatters off cometary dust, it becomes polarized in a characteristic way. Normally, comets show some negative polarization, with the electric vectors oscillating opposite to the Sun-comet line, but at moderate levels. 3I Atlas, however, exhibited a level of negative polarization stronger than any known comet. This is intriguing, but it too can be tied to dust physics. Polarization depends on the dust, grain size distribution, the grain shape, and the grain composition. If 3I Atlas's coma were full of extremely fluffy or highly carbon-rich grains, that could boost the negative polarization. Wright notes that negative polarization is normal for comets. 3I Atlas's value is simply on the extreme tail of what is physically possible. In short, 3I Atlas might have an unusual dust population, perhaps as a relic of its parent system, rather than a hint of technology. No one suggests that extraterrestrial machines are intentionally coated to polarize light. Another coincidence Loeb mentions is the object's arrival direction, roughly within 10 degrees of where the legendary 1977 WOW radio signal came from. He calculates a low probability for that, implying significance. But astronomers rightly dismiss this. First, 9 degrees on the sky is a huge uncertainty region. 3I Atlas was not aimed squarely at the WOW source, just loosely in the same broad direction. Second, the WOW signal itself remains unexplained, and most specialists in the search for extraterrestrial intelligence now suspect it was an instrumental glitch. There is absolutely no physical link between a random interstellar comet's path and a one-time radio blip detected decades ago. This is a classic Texas sharpshooter effect. Once you have a list of anomalies, you search the sky for something famous in that region and then claim significance. But there is no underlying mechanism, only a coincidence of sky coordinates that scientists consider meaningless. Near perihelion, 3I Atlas brightened with dazzling speed and showed a bluer hue than the Sun. Loeb's team says it brightened faster than any known comet. This is certainly dramatic, but again can be understood naturally. Comets from interstellar space may warm up more quickly because they are unused to intense solar heating, leading to sudden flares. Also, the colour, a bluer tint, comes from the gases and dust being released. Some comets emit large amounts of carbon monoxide and cyanide gas, which scatter blue light strongly. Indeed, other comets have appeared bluer than the Sun when rich in certain volatiles. Wright points out that a quick brightening is exactly what one would expect if 3I Atlas came in at high speed on a steep trajectory. It crosses the inner solar system quickly, so its ice sublimates rapidly, making it brighten rapidly. There is nothing unnatural about that. It is simply an outgassing spike. So fast brightening and colour do not require anything beyond normal volatile physics. The last two anomalies Loeb lists concern the jets and the thrust. First, he calculates that the nearly symmetric jets, sunward and antisolar, seen stretching out 1 million kilometres, would require an unreasonably large surface area to sustain. In one of his blog posts, he works out the comet's mass and energy balance. Roughly a few billion tons per month of carbon dioxide were being ejected at around 400 meters per second, the expected gas sound speed at that distance. Sublimating that carbon dioxide at roughly 600 joules per gram requires on the order of 3 times 10 to the 18th power joules of energy. Given the Sun's output at that distance, about 700 joules per square metre per second, 3I Atlas would need about 1,600 square kilometres of sunlit ice to power that outflow. For a solid sphere, that corresponds to a diameter of about 23 kilometres, 4 times larger than the roughly 5.6 kilometres upper limit seen by Hubble. If water ice were the driver, even 51 kilometres would be needed. Loeb declared this a "Houston, we have a problem" moment for a normal comet. The implication is that an intact 6-kilometre or smaller object cannot be supplying so much momentum unless something is off. Perhaps it's split into pieces, increasing its surface area, or it is not powered by sunlight at all, but by some other force. However, comet experts note flaws in this argument. In comet tails, the vast majority of dust is very small and feels solar radiation pressure, not solar wind, forcing it away from the Sun. Radiation pressure exceeds the wind ram pressure by roughly 1,000 times for typical dust grains. In effect, tiny particles are blown into the antisolar tail almost immediately after release. Only larger grains, millimetres to centimetres, can keep pace around the nucleus and form a sunward structure. Loeb energy calculation implicitly assumed all the outflowing material, the 5 billion tons, remained near the nucleus and had to be sublimated on its surface. But in reality, once gas and dust are ejected, they disperse quickly into a diffuse coma and tail. You cannot assume the entire ejected mass came from a localized patch that needed intense heating. In many comets, the total sublimating area is effectively much larger because jets break up into clouds, and the coma itself and any chunks adds surface area. Indeed, if 3I Atlas had fragmented or shed pieces, its effective area for sunlight could be far greater than that of the nucleus alone. Loeb himself notes that to reach the needed 16 times increase in surface-to-mass ratio, the comet would have had to split into at least 16 equal chunks. If it stayed intact, then maybe only an engineered thruster could produce continuous jets without melting away the ice. But since images after perihelion show a single body, scientists suspect the comet did break apart, and it could simply have shattered under solar heating, launching many fragments and hence a large combined surface into space. Indeed, observing 3I Atlas in November, astronomers found a bright, fuzzy coma but no obvious fragments. The Nordic Optical Telescope and the R. Naves Observatory in Spain saw it as a compact glow. Scientists like Qicheng Zhang at Lowell Observatory comment that all the images I have seen show a fairly ordinary healthy-looking comet with no sign at all of breakup. So the lack of fragmentation suggests that most of the dust and gas is dispersed in the coma and tails, not clinging near the nucleus. Therefore, Loeb energy area anomaly is likely moot, because normal radiation physics carries the ejector away. Wright and others emphasize that one should not expect to see all the missing mass in post-perihelion images, since the gas becomes too tenuous to detect as it expands. In short, that huge energy problem arises only if you assume every last bit of matter had to be heated at the surface, and real comets do not behave that way. Steve Desch, a prominent comet expert, flatly says Loeb tail length calculation is 100% wrong because it ignores solar radiation pressure on dust. The very jets staying aligned without smearing Loeb 12th anomaly also has plausible cometary explanations. Early November images. November 8 and 9 show narrow jets extending about 1 million kilometers on both sides of the nucleus. If the nucleus were freely rotating every 16 hours, one might think these jets would twist into spirals or smear out along the orbit. Loeb suggests it is odd that the jets appear straight. However, he himself notes that if the jets come from icy pockets in shaded terrain, deep valleys or pits, those spots would only sublimate when sunlight hits at the right angle. This could produce pulsating jets puffs at regular intervals of 16.16 hours, effectively acting like a strobe. You would see a string of blobs peas on a pod, separated by roughly 23,000 kilometers, 400 meters per second, times 16.16 hours along the jet direction. All these pulses would line up with the sun until that vent goes dark. This mechanism, seasonally or rotationally modulated outgassing, is well known in comet studies. In fact, one of Loeb's papers on this very object with Eric Quito explicitly uses ordinary sublimation physics to explain the sunward jet, even citing Comet Farnham et al. 2021 for precedent. Through careful analysis of each claimed anomaly, the scientific community has demonstrated that 3I Atlas, while unusual, can be explained through well-understood cometary physics and natural processes. Rather than evidence of artificial origin, 3I Atlas represents the remarkable diversity and complexity that nature can produce in these ancient wanderers from distant stellar systems. The rigorous application of scientific method, peer review, and evidence-based analysis continues to reveal the extraordinary within the natural world. Another idea is that the jets might actually be the trails of fragments. If 3I Atlas temporarily fragmented near perihelion and then reassembled, each chunk would have its own wake of gas and dust. The trails of those pieces would naturally line up along the comet orbit, mimicking a jet. Loeb mentioned this as a possibility. The observed features could be the evaporating trails of fragments, implying 3I Atlas did break up as it neared the Sun. Astronomers are indeed keen to verify if the nucleus later separated into pieces as Comet Shoemaker Levy 9 did at Jupiter in 1994. If 3I Atlas did not actually explode, we have another explanation. With all these natural processes on the table, what has the broader community said? Many comet scientists and observers remain convinced that 3I Atlas is an extreme but natural comet. A flurry of popular articles has noted that every time something seems inexplicable, the standard comet picture covers it. One science reporter summarized that our favorite interstellar visitor most likely did not just explode, and indeed most experts consider it normal. Lowell Observatory Chichengjiang told Live Science that all the images I have seen show a fairly ordinary, healthy-looking comet. There is no sign at all that the nucleus broke apart. He and others point out that astronomers should actually be thrilled by 3I Atlas' natural story, because it is only the third interstellar comet known. It is the most massive we have seen, and possibly the oldest comet observed billions of years old. The chance to study a completely alien comet is a rare treat, and many emphasize we should not be disappointed just because it is not engineered. As one review put it, 3I Atlas natural origins should be cause for excitement, not disappointment. Enter Jason Wright of Penn State, an astronomer with SETI interests who has taken a close look at all Loeb's claims. Wright, who initially defended the possibility of aliens years ago, now systematically debunks each anomaly of 3I Atlas on his blog. He points out that for every way 3I Atlas is acting anomalous, there are at least a dozen ways it is acting exactly like a comet, and not like an alien spacecraft. He walks through Loeb's list one by one, explaining the normal physics behind each effect, or noting when Loeb's math is mistaken. For example, he shows that the nickel excess and low water ratio are fully consistent with some comets at large distance. He notes that negative polarization is simply part of comet dust behavior. It is a very comet thing to do, albeit extreme, and has no reason to be more extreme if 3I Atlas were a spaceship. He ridicules the WOW alignment by pointing out 9 degrees is a long way away and effectively meaningless. When Loeb claimed 13% mass loss requiring thrusters, Wright counters that losing 13% of a comet's mass near the Sun is exactly what one expects. Comets are mostly ice, and brightening by that much mass loss is typical if the body is intact. Moreover, he emphasizes that Loeb is ignoring decades of comet science in making these claims. Indeed, peer critique has been blistering. In a Live Science interview, astronomers were quoted saying Loeb's posts look like a house of cards built on misinterpreted data. Jason Wright himself noted that Loeb's accusations often betray a lack of familiarity with well-established comet concepts. Wright's blog post on November 9, 2025, meticulously goes through 10 of Loeb's anomalies, explaining why each can be generated by normal physics. His tone is blunt. Where Loeb sees only aliens, Wright sees observational complexity. He even takes on Loeb personally, pointing out that Loeb's specialty is not solar system comets, so he should consult planetary scientists rather than reinvent basic cometary equations. In sum, the mainstream response is that there is no convincing evidence for alien technology in the data. Only lots of interesting comet behavior that will teach us new things about icy bodies from afar. At the end of the day, the verdict rests on physics. Can 3I Atlas's behavior be all in line with cometary mechanisms, or are there fatal gaps? So far, all signs point to the former. The object's sunward and anti-solar jets, rapid brightening and composition oddities are within the envelope of known comet diversity, just at the extremes. For instance, solar heating can vaporize deep pockets of CO2 and carbon monoxide on 3I Atlas and fling out billions of tons of gas and dust in a matter of weeks, naturally explaining the accelerating spin-up and tail shapes. The lack of a visible breakup does not contradict this. Radiation pressure simply cleared out the debris. The fixed jet orientation may be surprising, but deep pit vents or fragment trails can make that happen without invoking thrusters. Even the predicted mass loss, 13 to 16%, fits if one realizes that comets near perihelion often shed a large fraction of their mass, just like Shoemaker-Levy 9 did at Jupiter. Can we answer all 12 mysteries? Not completely. Unusual comets always have novel quirks, but crucially, none of them demands a non-geological cause. As 3I Atlas continues on its path away from the Sun, astronomers will keep watching. It brushes past Mars soon, then heads home to interstellar space by early 2026. They will take spectra and images, checking if it really did split into fragments or if those jets fade normally. For now, the scientific majority view is that 3I Atlas is a weird but natural comet. The new data have forced us to push our comet models to understand how an object 30 to 40 meters across or larger can emit such narrow jets, an exotic gas species. In that sense, it is a victory for cometary science. Every spectacular anomaly forces us to refine our understanding of sublimation physics, dust dynamics, and the formation history of such bodies. Questions remain for sure, and they will keep minds sharp. For instance, why exactly is the nickel-to-cyanide ratio so high, or why the polarization so extreme? Are there unknown chemical processes at work in interstellar ices? How do contact binaries or jet geometries factor into the story? These are the genuine scientific puzzles, but the answers are expected to lie in rock and ice and radiation, not in software or thrusters. Ultimately, the news that 3I Atlas cannot be a comet is not so clear-cut. The object continues to fly by in perfect accord with gravity and solar radiation. Every novelty it presents has been matched by a well-rooted natural explanation or an ongoing test. In the cosmic detective story, the science investigators say, "Do not be fooled by sensational headlines. This is one of nature's own puzzles, not a manufactured one." Hit that like button, share this with everyone who needs to see it, and subscribe so you never miss out. And don't forget to smash the hype icon. Let's get this video trending far and wide.